Purpose of this lesson is to show you how to calculate irregular areas. Okay, a lot of it you would have probably done in the past, so it's really just a quick review. And just a reminder on the different formulas. So if you've got a rectangle, the area is the length times the width, okay, and you'd use that in your formula. So say you're trying to find the area of a rectangle 6 centimeters by 5 centimeters. The working would just be area equals length times width. Okay, 6 times 5, and you get 30. What should the units be? It's all in centimeters. Okay, so it'd be in centimeters squared. Okay, that sort of working's all that's required. For area of a circle, okay, pi times the radius squared. So just as a little example, okay, if I had a circle, say a circular field, okay, with a 50 meter diameter, okay, I would find, okay, the radius is half of the diameter, so the radius is 25 meters, and then I'll just find the area. So pi times 25 squared, and then I'll be off to my calculator. And to find pi, it's shift and the EXP key. Pi times 25 squared. A1963.49. Okay, the units are meters squared. Area of a triangle, like we've discussed before, half of base times height. Okay, or you could use area equals base times height divided by 2, whichever one you want, as long as you have the base and something that's at right angles to the base. Okay, last one that you probably may not be quite familiar with, trapezium. Okay, formula half of a plus b times h. So a and b are the two lines that are parallel, okay, that are going in the same direction. And h is the distance between those lines. Okay, and we'll do an example of that. Do an example now. So suppose I had a shape like this. Okay, so this is 5 meters. This is 2 kilometers, and this is 3 kilometers. Okay, I wanted to find the area. My formula for area is a half a plus b times h. Okay, I can't just substitute the values in at the moment because some are in kilometers, some are in meters. So I'd make sure I write that this is 3,000 meters, this is 2,000 meters. Okay, and then I can go about looking at the formula. Do I have two parallel lines? Yep, there's one parallel line, there's another parallel line. So I could say this is A, this is B. So my area would be a half of 2,000 plus 3,000, okay, times h, which is the distance between those two parallel lines, which in our scenario is 5. Okay, and then off to our calculator land. Okay, to find what that area is. A half, or 0.5, times, need brackets, 2,000 plus 3,000 times 5. Okay, 12,500 meters squared. Okay, all good? Alright, so the main problems that you'll be solving are ones that essentially look like this, where you need to break a bigger irregular area into two smaller shapes. So if I was doing this problem, I'd say let this be area 1, let this one be area 2, and I'll try and find the total area just by finding the area of these two smaller shapes. So area 1, I'm recognizing is a trapezium. I might even draw the basic shape just so I've got it here handy. Okay, I know my formula for trapezium is a half a plus b h. Okay. This can be my a, this can be my b, this can be my h. So the area of this one would be 64 plus 92 times 28. Okay, and then off to the calculator for this one. a half or 0.5 times 64 plus 92 times 28, 2184, and they're meters squared. Okay, all good so far. Now I'll have a look at area 2. It's a triangle. There's no right angle there, so I'll need to use Heron's formula. Okay, so area 2, I'll get a triangle which is 92 by 45 by 57. Okay, just like the little area that we surveyed outside. Okay, so to find this area using Heron's formula, remember S minus A, S minus B, S minus C, okay, where S is A plus B plus C, all divided by 2. So I'll do that. It doesn't matter how we label these, I'll just do this for consistency. Okay, 92 plus 45 plus 57, all divided by 2 is my S value. Okay, we're going to be spending a lot of time on our calculators, so you better make sure that you have it. Okay, 97 for S, and then I can do my big Heron's formula. 97 minus 92, 97 minus 45, 97 minus 57. Okay, off to the calculator. So I want the square root of 97. I'll make it look like your calculator. 97 times 97 minus 92 times 97 minus 45 times 97 minus 57. 1004.39. Okay, and again, that's in meters squared. Okay, so remember I was trying to find the total area of that reserve, so I'm going to need to add these two areas together. And I'll just show this by saying that the total area is area 1 plus area 2. Write it a little bit neater. Okay, and substitute these values in. Okay, add them together. I've already got that one sitting there, so I'll just add. Okay, if you just press plus, it should come up like this. Plus 2184. I get 3188.39 as my total area. Okay, so for you, off to these questions, have a go, and I'll help you out during class.